This video is for learning and conceptual clarity only. Students must not reproduce answers blindly or mention YouTube as the source during practical examinations. Always justify the procedure and results in your own words as per the prescribed syllabus and lab record. The creator, Juanita, is not responsible for any outcomes, results, or actions performed in the laboratory based on this video. Thank you. Okay, so the next experiment that we have is voltmeter. In this particular experiment, you will be using your galvanometer and you will convert it into a voltmeter by connecting in series a very high resistance. Let's look at the circuit diagram. Yes, over here the equipments you need are your voltmeter, okay, and as you can see your galvanometer is connected in series with your resistance box. You also have a rheostat and a battery key. This key we are not going to use it in the experiment, however you need to draw it in the diagram. So place all the equipments just like how they are placed in your circuit diagram. Alright, here you have the voltmeter, here you have the galvanometer, here you have the resistance box, here you have your rheostat, and here you have your battery. Okay. Just like how it's given in your diagram, connect the positive of your voltmeter to the left hand end of your galvanometer. Okay. As you can see, the positive of your voltmeter is connected to the left hand side of your galvanometer. This is the right hand side, right? That is connected to the left hand side of your resistance box. If you want me to write it down, this is the left hand side of your galvanometer. This is your right hand side of your galvanometer. This is your resistance box. This will be the left hand side. This will be the right hand side. So take a wire from the positive of voltmeter, you connect it to the left hand side of the galvanometer, and then the right hand knob of your galvanometer connected to the left hand knob of your resistance box, and then the right hand side of your resistance box is connected to the negative of your voltmeter. This will be your first loop. The positive end of your voltmeter is connected to the left hand side of your galvanometer. The right hand end of your galvanometer is connected to the left hand end of your resistance box. Now the right hand end of your resistance box is connected to your negative terminal of your voltmeter. This is the first loop. This is the second loop, and then this is another connection from your left hand side of the galvanometer to the lower terminal of the rheostat. Again, this is the lower terminal of the rheostat, and this is also the other lower terminal of the rheostat. This will be the upper terminal. The left hand side of your galvanometer, which is this, is connected to the lower end of your rheostat. Yes. Then, and the upper terminal of my rheostat is connected to the the right hand side of my resistance box, which is here. Second loop is also done. Now I will connect the third loop. How does the third loop go? Take another wire, connect it from the left hand end of your rheostat to the positive end of your battery, and from the negative end of the battery you will be connecting it to the right hand lower side of your rheostat. Let's lower end, left hand side lower end of my rheostat to the positive of my battery, and then from the negative of my battery to other lower end of my rheostat. So this is the 10 kilo ohm knob that you will not be using. These 4 knobs are the knobs that you will be using. This is the 1 kilo ohm knob, this is the 100 ohm knob, this is the 10 ohm knob, and this is the 1 ohm knob. Okay, so this is the observation for the voltmeter experiment. The resistance of the galvanometer G will be given to you We'll be taking it as 45 ohms as of now. The figure of merit of the galvanometer K is 1.65 into 10 raised to minus 5 ampere per division. The third one that you have to study is the number of divisions on either side of 0 on your galvanometer. It is denoted by the letter capital N. And on either side of the galvanometer, you would have 30 divisions. Okay, on this end, you would have 130. On the other hand, you would have another 30. So it is 30 divisions. The fourth one is the current required for producing full-scale deflection of N division is given by the formula Ig is equal to N into K, where N is nothing but number of divisions into K, which is nothing but the figure of merit of the galvanometer. Okay, so now multiply. To get Ig, you will multiply N into K. N is nothing but 30. K is nothing but 1.65 into 10 raised to minus 5. When you multiply these two, you will be getting 49.5 into 10 raised to minus 5 ampere. Okay, so now this is essential. It's very, very important. The maximum voltage to be measured, V, is equal to 1.5 voltage. In your voltmeter experiment, this voltage will be kept constant all throughout the experiment. Okay, and this value in your final exam, it will be given to you either by your external or your internal. Okay, for this setup, for the calculations that I'm showing to you as of now, I will be using the value 1.5 volt. So I'll repeat it again. You have to be extremely careful. You have to maintain a voltage of 1.5 volts all throughout the experiment. And again, it's not necessary that you have to take 1.5 volts. Yes, this will be given to you in the exam by your examiner. Up next, you have the formula. Formula is given by R, which is the resistance, theoretical resistance, is equal to V divided by Ig minus G. V is nothing but, what is it? It's the maximum voltage to be measured. Alright, Ig is the current through your galvanometer, and G, it is nothing but the resistance of your galvanometer. The next thing that we shall do is substitute the values. We know that V is nothing but 1.5 divided by Ig is 49.5 into 10 raised to minus 5 minus 45. Okay, the next thing that you do is, the next thing that you will be doing is this 10 raised to minus 5 that is there, get it to the numerator. When you get it to the numerator, what happens is that the minus sign gets converted to a positive sign. So you will be getting 1.5 into 10 raised to 5 divided by 49.5 minus 45. This is nothing but 150,000 divided by 49.5 minus 45. Alright, what do you do after this? When you divide this using your calculator, that is when you divide 1,50,000 by 49.5, you will be getting 3030, okay, minus this 45. So my final answer would be 2985 ohm. Therefore, your theoretical resistance R is 2985 ohm. Therefore, when you open the result and see, it's given as the value of the calculated series resistance is nothing but how much? 2985 ohm. Now you need to make sure that your practical result is pretty close to this range. If your, since your theoretical value is 2985, you should not be getting a value like your practical value shouldn't be 3505. No, it shouldn't be that high. Neither should it be as low as 2505. You should always make sure that your resistance value is around plus or minus 200 of this value. That is, it can be 2985 plus 200 or 2985 minus 200. Okay, theoretical resistance that we've calculated is 2985 ohm. So first knob we're never going to use. Second knob, since it is 2985 ohm, move this knob to 2. So that would become 2 into 1 kilo ohm, which is nothing but 2 kilo ohm. Now 985 is left. Move your third knob to 9. Okay. Then move your fourth knob to 8. And then your finalmost knob, move it to 5. Why? Because your resistance value is 2985. This resistance is nothing but the theoretical resistance. And then the other thing that you have to be cautious about is that in the voltmeter experiment, voltage is kept constant all throughout. As you can see in the voltmeter, right now, voltage value is not 1.5. So we will use the slider of the rheostat. We will use the slider of the rheostat and push it to 1.5 on your voltmeter. Yes, right now it's at 1.5. The next thing that you have to do is you have to look at your galvanometer. Now as you can see on your galvanometer, this needle is not exactly on 30. Our aim is to move these knobs in such a way that you will get full scale deflection on the galvanometer. That is, the needle should come and fall on your 30th line. So because of that, I will be changing these values. Now please turn the knobs, your resistance knobs, so that this needle falls correctly on 30. So when you move this 1 kilo ohm knob, you can see that this went out of range, right? So push it to its original position. Then go on to a knob that has lower value. This is 100 ohm. Decrease it. Decrease it. As you can see, it is fallen. Go closer. It is beyond 30. So increase the value of your resistance first, second, third, fourth resistance knob, so that you will get full scale deflection on your galvanometer. And after that, what you have to do to get the experimental resistance value is that you need to note down these values. As you can see, right now it is at 2 kilo ohm. So that would be 2000. That would be 2000 ohm. Add it. Go to the next knob. This is nothing but 7 into 100 ohm. So write it as 700 ohm. Your third knob is 9 into 10. So that would be 90 ohm. And then finally you have your last knob, which is nothing but 5 ohm. So this would be 5 ohm. Once you add it up, what will you get? 2795 ohm. This will be your experimental resistance. Thank you all for watching. Kindly like, share and subscribe. And if you want more videos in the future based on mathematics or physics, kindly let me know. Thank you.